Welcome to the fifth video in our quantum physics series. Today we will take a look at a thought experiment proposed by James Clerk Maxwell in 1867 that seemed to contradict the second law of thermodynamics. You see, the universe follows some pretty strict rules, and one of these is that heat always flows from hotter to colder regions of matter. Put in terms of entropy, which is a measure of randomness, this principle states that the entropy of an isolated system left to spontaneous evolution will increase over time. Imagine a box divided into two chambers with gas molecules bouncing around. The left chamber's temperature is higher than that of the right chamber. But remember that temperature is a macrostate, meaning it describes the average kinetic energy of this very complex set of particles. This means that some of the individual particles in the hot chamber might be traveling at slow speeds, and some of the particles in the cold chamber may have a higher kinetic energy than the average. Now meet our demon. Maxwell referred to him as a being who can play a game of skill with the molecules, but let's just stick to demon for short, as Lord Kelvin named him. Our demon opens a door between the two chambers, and every time he sees a fast-moving particle approaching from the right chamber, he lets it pass to the left. When the demon sees a slow-moving particle approaching the door, he does the opposite and allows it to pass to the right. In any other case, he just shuts the door and the particle bounces. By doing this, and maybe he'll spend 1 billion years doing so, the demon will separate all fast-moving particles from all slow-moving particles, which means that the average kinetic energy of the left chamber will have increased, its temperature will have risen, and the opposite goes for the right chamber. However, this means that the energy from the cold chamber has flowed towards the hot one. Without applying any energy to the system, the demon has reduced its total entropy. Now we could even use a heat engine to do some work. But isn't that a direct contradiction of the second law of thermodynamics? Many have attempted to give this paradox an explanation. Leo Szilard, for example, argued that the demon's act of measuring molecular speed means spending energy. Since the demon is interacting with the gas, we must consider it as part of the same system. By measuring the particle's speed, the demon creates an increase in entropy that is larger than the gas's lowering of entropy. Nonetheless, reversible measurements can detect the particle's speed and open the door without increasing the system's entropy. However, every possible system has an unavoidable step: storing information. In order to open or close the door, the demon must remember, the particle's velocity. Since the demon can't have infinite storage, he will eventually need to erase information. This, as Rolf Londayer proved, is an irreversible process that will increase the system's entropy. In conclusion, no one can escape the second law of thermodynamics, but contending with this seemingly paradoxical demon has propelled innovations in quantum computing. For example, researchers at the University of New South Wales use this principle to guarantee that an electron is stable enough so as to make a quantum computation with it. Thank you very much for staying until the end of the video. We hope this is at least some valuable entropy. Keep tuned!